Welcome to the stage, Daniel Cohen Dumani.
Good afternoon, everybody. I know I'm the last one today, so I thank you all for sticking here. Hopefully you'll find the best presentation today, but I hope you enjoyed the conference so far. I want to tell you that I was here last year, and it's been an inspiration for me. Actually got me to think about starting my next venture. So I'm very excited today to talk about how to build the foundation for AI-driven business insights. So a little bit about me. I'm the founder and CEO of Experio Labs, and we're bringing to market a product called Experio AI. I'm a reformed consultant on a mission to fix the consulting and professional services industry. I'm really passionate about this concept of organizational memory and consciousness, and I'm obsessed in turning decades of consulting chaos into clarity. And a bit more about me, I was born in Switzerland, and as you know, all Swiss people are obsessed with precision. And what I'm going to talk today about you is how do we get precision into artificial intelligence? So before we start, I would love to hear if someone wants to tell me what's the biggest AI opportunity that you're worried or that your organization might be missing out on right now. Anyone want to say something? You're not fearing anything? All right, so is it unlocking hidden insight from our data, breaking down silos for a unified view, faster and more accurate business decision, staying ahead of competitor with AI? This is things I hear all the time when I talk to customers. Or you're not sure, but I'm sure many of you don't want to be left out. So why do business struggle with AI insights? There are a lot of reasons. The first one, I'm sure you'll all agree that all of your business has a lot of fragmented data across a lot of disparate systems and departments, and that makes it very difficult to gain a holistic view of your business. You have a CRM, ERP system, document management system, email, Slack, Teams, everything, everywhere. Everything is manual. People spend a lot of time searching data in a lot of different systems. Traditional search engine and even AI-powered search engine that we've seen over the last couple of years, search often struggle to provide relevant and contextual results for complex business queries. And lastly, insights often lack context to drive strategic decision-making. It's one thing to get data, but if they're out of context, it's not being helpful. And overall, we believe, and I believe, that business requires a unified contextual approach to data and insight to make the informed and strategic decision at a real speed. So I want to introduce a concept to you called knowledge graphs. Raise your hand if you heard what a knowledge graph is. I see a few hands, hard to see, but not a lot. So a knowledge graph is a way of organizing and connecting data to provide richer context and understanding. It's a type of data model that represents information as a network of interconnected nodes, often called entities, and edges, called relationships sometimes, rather than in traditional tabular or table format or hierarchical format. As a matter of fact, knowledge graphs aren't new at all. In the 1950s, we were talking about semantic networks. This evolved into other type of network in the 90s. And then in 2012, Google introduced the first production-used knowledge graph. This was a technology they embedded in their search, was very minimal in the beginning, but provided a connection between people, places, and other relationships. Knowledge graphs since then have been used extensively in intelligence, government, financial services for fraud detection, and drug discovery. heavily used in that space. But what is new? Why am I talking about knowledge graph today? What's new is that for the last 18 months or so, really since the release of GPT-4-like models, we now have the ability to construct those knowledge graphs not only from structured data, but from unstructured data, from documents. And I'm going to take you through that process today. So again, the knowledge graph definition is a structured representation of information and relationship between entities, attributes, and their connection. So a knowledge graph has entities, often called concepts or nodes. One of the challenges with knowledge graph is there's a lot of different terminology and standard, but entity, nodes, and concept means the same thing. So an entity can be an object, a concept, or things that is represented in the graph. Usually it's a circle. Relationship is what connects entities, and I'll give you some real example in a second. And then lastly, attributes give additional details on entities and relationship, such as characteristics and more context about each of those entities and relationship. So let's take an example here. So hopefully you've seen the website, right? The website is technically considered unstructured data sets. It's a bunch of text. And if you give it to an LLM, yeah, it may understand it, but it's just going to look at the text. I've highlighted in yellow a few concepts. The knowledge graph is part of the title, the date, my name, and my title. So let's construct a knowledge graph. I want to represent a small part of that text. Me, Daniel, I'm a person, right? Person is a concept. Daniel is actually the node in the graph. You'll see in the bottom, I have some attributes. Title, I'm a founder. My company is called Experio Labs. The other concept we'll find lower in the text is Las Vegas. Well, we're in Las Vegas, well, so that's the show. And Las Vegas is a place. Las Vegas as a state and a country. And then we have a relationship. Daniel is presenting in Las Vegas on 5/30/2025. The subject of the presentation is about knowledge graph. So what did we do here? We read a document and structured that document in something that is highly structured. And why is that so powerful? Because we all know that large language models are statistical, super fast machines, but they don't understand meaning. But when I ask a question, where is Daniel on May 30th? And I go in that graph, I can filter the date, find Daniel, and see that Daniel is in Las Vegas. So now a large language model or chatbot can answer a question with a lot of precision. It's not a guess, right? The knowledge graph here has been traversed to find the answer. Another concept we find in knowledge graph is this concept of ontology. It's a very fancy term to talk about schema or data model. So here's an example of an ontology. One of the challenges with knowledge graph is you have to define the domain of the graph. Remember before the domain was person and location. That was my domain. And there was a relationship that a person was at a location. This is another example of an ontology where we have location, city, and country, and we have point of interest, one region, and building of interest. And then underneath that, we have the instance of the graph. A graph is always based on an ontology. Why? Because the ontology is what gives meaning. If you have a chatbot and you give it an ontology and say, go in the graph and find me an answer, you bet it's going to be an exact, precise answer with 100% accuracy. So we talked a lot, you all heard about retrieval augmented generation, right? Raise your hand if you've had many, right? So retrieval augmented generation has been something that came out roughly about 2 years ago, maybe 6 months after ChatGPT 3.5 was released, Microsoft was the first one to implement RAG with Bing. You remember Bing AI? This was ChatGPT with Retrieval Augmented generation, which is combining large language model with external knowledge. You probably all know a large language model is trained on all the data set in the world, everything. But to a certain point, it costs a lot of money, a lot of time, a lot of compute to train a large language model. That's why they stop. RAG gives you the ability to go out and say, let's go search for additional content, maybe private data set in your enterprise or external data sources. So we combine the knowledge of an LLM with external data source. So that's what we call traditional RAG. It's been around for 2 years. If you use any system like Perplexity, is doing a lot of RAG. Any ChatGPT on data that are external on a document is doing a retrieval augmented generation. But there are a lot of limitations on RAG. You are limited by the document level granularity and the inability to extract fine-grained information from a lot of sources. If you try to find the needle in the haystack that's, a contract that's 200 pages and there's a clause that does something specific, and you're gonna do for a RAG system, guess what? It's gonna hallucinate. It's gonna give you maybe a right answer sometimes, but more often than not, the wrong answer. So what came out literally about 14, 16 months ago was the concept of graph RAG. What if we did retrieval augmented generation, but we did that on a RAG? This is a graph you can see, but there's a link, and if you send me your information at the end, I'll send you a copy of this presentation. Very interesting article on talking about graph RAG. But essentially, on the left side of the screen, you'll find what a traditional RAG is, vector database. So the LLM, as you know, all deal with numerical data. Every word is chunked into little bits of token, and token is made a numerical representation, like we can see on top. And those chunks are indexed and put in a database. And guess what? When you ask a question, that question is transformed in a numerical sequence, and that sequence is compared to whatever we find that looks the same. So AI is just a big box that's able to statistically give you something that looks very relevant, very close, but it's still similarity searching. So when you work in high-stake environment, being similar enough is not good enough. So look on the other side of the screen, on the right-hand side, we have a graph database. Now the challenge with graph database or graph extraction, you need to read the content and extract everything you need based on your ontology. That's done on top. Then you populate that in a graph. A graph may have billions of nodes. As a matter of fact, our brain is a graph database to sort, right? We have neurons in connection. We just have trillions of those and things we don't even know about, but a graph database is similar to what we see in the brain. Now, when you ask a question, here's the power. Instead of doing a similarity search and trying to find numerical value that looks alike, we are traversing the graph to find an answer that's close to what you've asked, and we output a subgraph of it. Oop. All right. Not sure what happened. Oh, there we go. And we output a subgraph of the results. Now you know that the subgraph is right, and more importantly, we can trace back how we find the answer. This is another view, another paper that was published about 16 months ago. And this one was very inspirational for me when I first read it, because it explains the difference between knowledge graph and large language model. So when you think about a large language model, I mentioned to all of you, on our phone today, we have access to the entire body of world knowledge. Everything to, I don't know, the last date of GPT-4 or the retraining date, I think it was 3 months ago, right? Everything is accessible, right? But remember, we're doing a vector-based type search, right? So large language models are fantastic because they have general knowledge of everything. They're really good at doing language processing, specifically English language. And it's getting better with other language. But the problem is they don't have implicit knowledge. They hallucinate a lot, sometimes 50%, 60% of the time. They are black box. Although there's a lot of work being done now to explain a large language model answer, it's still a black box, right? Have you ever had sometimes an example where you ask a chatbot or ChatGPT or whatever, Claude, 5 times the same question and you got 4 different answers? They are non-deterministic. It's a black box. You can't explain why you got separate answers. And of course, they lack domain-specific knowledge. They're good at general knowledge. Now, the knowledge graph, however, contains structural knowledge. They're accurate. You can trace and interpret why and how you got an answer. And they contain domain-specific knowledge. So really good to model things that are private to your organization or that you want to get very precise answer. Now, where it's interesting, and what happened again 18 months ago was this fusion of LLM and knowledge graph. Prior to GPT-4, we didn't know how to effectively read content and create a knowledge graph. And that changed with the GPT-4 model. So you can enhance knowledge graph with an LLM. You give an LLM a knowledge graph, and all of a sudden your LLM becomes intelligent. But you also need LLM to construct your knowledge graph. Goes hand in hand. Now, often you use different LLM. Sometimes you may use a small language model or purpose-built LLM to build the graph. But they essentially work themselves in a loop. The factual knowledge is given to the LLM who's providing the knowledge representation back and forth. So why does graph RAG and graph and knowledge graph and using RAG with knowledge graph matters for business? First, business have a lot of dynamic and interconnected system, and now you can provide interconnected understanding, not just keyword search. You can improve accuracy, transparency, and explainability. This is key for a lot of industries. And last, they can scale to complex cross-domain queries. Now you can ask a question. Imagine a knowledge graph being populated from all of your system. Documents, CRM, ERP system, all modeled into a very comprehensive structure. So let me give you a case study. This is what we're building at Experio. So Experio Lab, we're bringing to market a product called Experio AI, which is the first agentic AI solution, SaaS solution, for the consulting and professional services industry. So I came from that industry. We're targeting to create an organization of memory and consciousness for consultants and services business. You can see here that building knowledge graph is a bit harder than just connecting an LLM to your data. So we have to connect in the bottom to all of your unstructured data set, like the SharePoint of the world, Google Drive, Slack, email, OneDrive, and Teams. And then on the other side, the ERP, CRM, and other transactional system. All of this gets put in, ingested on a continuous real-time basis. If it's a document, we have to classify, extract, infer. And then if it's a system of record, we have a rule-based extraction to our knowledge graph. And then all of this is put into a knowledge graph database. We use Neo4j. There's a lot of new graph database now that can scale to billions and trillions of nodes. And then on top, we have a web application that's talking to this organizational memory with an agentic framework. So the result is we have a chatbot interface that when you ask a question, if we give you an answer, it's going to be the 99.5% accuracy. I would say we're at 95 now. By the way, human accuracy in search is about 90%. So, it's hard to think that anyone can reach 100% when us as humans are not 100%. But for all intensive purposes, we're able to reach very, very high accuracy. This is an example where in the world of consulting, we spend a lot of time generating case studies of our past work. And it's still a very manual process. You go interview people. What did you do on this project? You talk to the client. Well, guess what? All of that information exists somewhere in digital form. We just don't know where it is. Well, because we've ingested all of that content, we can generate a case study on the fly in like 2 seconds on anything. And you can make change as you go. So, we talked about graph rag. It's not that easy. But because if it was easy, one, we wouldn't be here, and then everybody would be using it. So there's a lot of challenge in implementing graph rag, and really start with your data. You have siloed data, so you need to identify where is your data set, what you want to model, right? And connect to all of those data sets to get the information in. More often than not, and we're talking about experience working with consulting or any industry in my past consulting experience, nobody knows what the data is. They don't know what it means. What is this? Where's my customer data? Why do I have customer data in both systems, right? So there's a poor schema. And today AI is not able to solve that on its own. Now you need humans to come and connect and give you, where's the data? Where's a good source of the data? Where we should put it in? And that brings the concern of governance. Most organizations are suffering with governance. And you probably have heard that if you want to build AI in your enterprise, you need a good governance on your data, right? On your data infrastructure, on your data modeling. Otherwise, you're going to bring a lot of garbage into an AI system. So what's the road ahead? So I've talked about this concept of organizational consciousness. I know that we had some talk about consciousness earlier or yesterday. But if you think about leveraging knowledge graph, you can unify disparate data source into one place. Imagine connecting your data document management system with your CRM system and doing that with AI automatically and seamlessly. You can provide contextual insights. So you can ask questions on your data where the data comes from all of those systems, financial data brought in with Excel spreadsheet, fusion with Word document all in one place, and you get really good insight that will drive better decision making. And then you can build a flexible knowledge foundation that will evolve with your organization needs. Knowledge graphs are very adaptable, scalable, and can adapt to a lot of environment. And unlike traditional database where you have a fixed schema, right, you're like stuck, knowledge graph can evolve as your organization evolves. So I'm going to leave you with a few key takeaways today. Knowledge graphs don't just organize data, they create this organizational consciousness that transforms decades of scattered information into actionable intelligence. And I mean really intelligence, not like the perceived intelligence of a large language model. That's real intelligence. Graph rag doesn't just find answer, it reveals hidden connection. One of the side effects we found with Experio is that we're able to connect concepts that we never thought about. Our clients are telling us, I didn't know that those things connected, because we were able to surface those insights because of connection that were not known or existed. But we also can provide traceability. And as we need to trust AI in the future, knowledge graph is one of the solutions to give more trust into your AI. And then, of course, the success isn't about perfect implementation. It's about creating adaptive foundation that evolves with your business and compound your competitive advantage over time. So I'm going to leave you with an important question. The question is, from my point of view, whether will you use knowledge graph in your future. It's whether you'll build them before your competitors do. So with that, I want to thank you for the time today. This QR code will go straight to my calendar. You can book a meeting. I'm very passionate about this. I'm happy to meet with all of you, talk about Knowledge Graph, talk about what we're doing at Experio, and give you more insight, share the proposal, the presentation with you. It's been a great show. I want to thank you, Steve, for bringing me here. Like I said, a year ago, I got really inspired about doing something new in AI, and here we are today. So thank you again for the time.
That's one.